Okay friends, welcome to Login Science. Today's video will be on Parabola grade 12 or Quadratic Functions grade 12. Okay, this is part 2 of 6. Part 1 of 6 was on linear functions. Part 3 of 6 will be on hyperbola. Okay, for now it is part 2 of 6 which is on parabola or quadratic functions. Okay, we start with the equation of a parabola. There are three forms that you have to know. The forms of the equation of a parabola. Okay, the three forms of the equation of a parabola. Let's start with this one. The first one is known as the standard form. Okay, the standard form is when we have the equation given in this form. F of x is equal to ax squared plus bx plus c. Okay, we are going to see that this is known as the standard form. You have to know that c represent what? Your y-intercept. Okay, so C is the y-intercept. Okay, so for example, let's say you are given this parabola, okay, and you can see the parabola is cutting the y-axis at that point, which is 3. Can you see that point there? So this is your C, okay. So C is telling you where the graph or the parabola is cutting the y-axis, okay. So C will be equal to 3 in this example, because the parabola is cutting the y-axis at 3. Okay, so the other form, which is known as the vertex form, it is when you are given the equation of a parabola in this form. F of x is equal to a, in bracket we have x minus b, you close your bracket, squared plus q. This is known as the vertex form. So for this one, you have to know that p is the x coordinate of the turning point. Okay, this is turning point. P is telling you what the x coordinate of the turning point is. Okay, you have to remember that. So when P is negative, this means that the parabola will shift P unit to the right. Okay, you have to remember this. When we have a negative, you know that negative is always associated with left. But when you have negative there, do the opposite. You have to know that when you have negative P, when the value of P is negative, the parabola is shifted P unit to the right. When P is positive, you have to know that the parabola is shifted P unit to the left. Okay, and what is the Q value telling you? The Q value is the y coordinate of the turning point. Okay, so when you have this vertex form, you can see that this is your x coordinate of the turning point and this is the y coordinate of the turning point. But remember, when you take it out of the bracket, you have to change the sign. So for example, if you have negative 3 there, when you take it out, it's going to be positive 3. So you know that the x coordinate of the turning point is a positive 3. When you have negative 3, the x coordinate is a positive 3. When you have plus 3, the x coordinate is a negative 3. So you have to change the sign when you take it out of the bracket. Please remember that. Okay, so what does Q do? Q, when you have a positive Q, Q shift the graph by Q unit upward. So this, you don't change it. When it's positive, upward. When it is negative, downward. So when Q is negative, the parabola shift Q unit downward. Okay, so it's going to make sense as we move on. So when you are given a graph like this, for example, you can see it cutting the x-axis at that point and at that point. So this is your turning point, which is there. The coordinate of this point will be P and Q. Okay, so you know that this is your x coordinate. It will be found there, right? So this is your P. In this case, you can see that P is equal to 5. This is 5, right? When you put it back there, it's going to be negative 5. When you put it back inside the bracket, it's going to be negative 5. But here it is a positive 5. Remember, when you put it back in the bracket, you change the sign. When you take it out of the bracket, you change the sign. Okay, for example, when you have negative 5 there, you take it out, it's going to be a positive 5. And this tells you that the x coordinate will be 5. But when you want to put it back inside the bracket, it's negative 5. Okay, it's going to make sense as we move on. And your Q is the y coordinate of the turning point. So you have it there, that point, it's Q. In this case, for example, q is equal to 9, you can see. So you can have plus 9 there, and your q is 9. But here, your p is 5. When you put it back there, it's going to be negative 5. Okay. Now, the third form of the equation is called the factored form. Okay. This is when you are given the equation in this form. F of x is equal to a. You have in bracket x minus x1 and another bracket x minus x2. Okay. So when you have it in this form, this tells you that the graph is cutting the x-axis at x1 and at x2. So x1 and x2 are the x-intercept. Okay. x1 and x2 are telling you where the parabola is cutting the x-axis. So for example, when you have this parabola, you can see the parabola is cutting the x-axis at that point. So this is your x1, and it is also cutting the x-axis at that point. This is your x2, right? You can see that. So this is the first x-intercept, and this is the second x-intercept. Okay, again, remember, when you take it back inside the bracket, you have to change the sign. Even when you take it out of the bracket, you have to change the sign. Okay, this is going to make sense as we move on. So for example, you can see for this parabola, you can see the parabola is cutting the x-axis at 2 and at 8. Can you see? At 2 and 8. So if you have to put it back in there, you are going to have minus 2. You can see it is a positive 2, but if you have to put it back there, it's going to be minus 2. And even this 8, if you have to put it back there, it's going to be minus 8. Okay, so this is going to make sense as we move on. Okay. Okay, now we are going to see the turning point of a parabola and axis of symmetry of a parabola. How can you find the turning point of a parabola and the axis of symmetry of a parabola if you are given any form of the equation of a parabola? Okay, so let's start with the standard form. When you have the standard form, this one, f of x is equal to ax squared plus bx plus c, how can you get the turning point? The x coordinate of the turning point, using this form, you can find it by using this formula. The x coordinate of the turning point is equal to negative b over 2a, right? When you have this form, you can find the x coordinate of the turning point using this formula. This formula is extracted from the quadratic formula. This formula, you can extract it from the quadratic formula. So you can use this formula to get the x coordinate of the turning point. After getting the x coordinate of the turning point, you are going to plug it in there and get the y coordinate of the turning point. Okay. Or you can use calculus. You take the first derivative of this equation, you equate it to 0, and you solve for the x coordinate, which is the x coordinate of the turning point. So when you are given this form, you can use this formula or use calculus. Okay, so you have the turning point with x coordinate and y coordinate. You can find it by using this or this, as I said. Okay, so you have this negative b over 2a. This is going to give you the x coordinate of the turning point. To find the y coordinate of the turning point, you take this, you plug in there. So this is going to be f of this, right? What you have there, the value you have there. You plug inside f of x and it's going to give you the y coordinate of the turning point. Okay, now how can you get the x coordinate of the turning point if you are given this form, the vertex form, this one? If you are given this one, how can you find the x coordinate of the turning point? You can see from this one, you don't need to stress. The x coordinate of the turning point is equal to p. Remember, you have to change the sign when you take it out of the bracket. So if you have negative 2 there, the x coordinate of the turning point is going to be 2. If you have plus 2, the x coordinate of the turning point is going to be negative 2. Okay, so this is going to make sense as we move on. Now you have your turning point with x coordinate and y coordinate. Okay, so this is equal to p, and the y coordinate of the turning point is equal to q, whatever you have there, whether it is plus or negative, do not change the sign. So the y coordinate of the turning point is equal to q. Okay, remember to change the sign only when you are taking p out of the bracket or inside the bracket. Okay, what if you are given this form, the factored form, which is this one? How can you find the x coordinate of the turning point? You can find the x coordinate of the turning point by taking this first x-intercept plus this second x-intercept. You divide by 2 because the x coordinate of the turning point is in between these 2 points. Okay, so this is going to make sense as we move on. So to get the x coordinate of the turning point when you are given this form, the factored form, you have to take the first x-intercept plus the second x-intercept. You divide by 2. So this is going to give you the x coordinate of the turning point. So you have your turning point with the x coordinate and the y coordinate. So this is equal to this when you calculate it, right? Okay. And the y coordinate, you have to take this, you plug inside f of x. Okay. So you are going to take f of this. Can you see? You take the value you have there, you plug inside f of x. You are going to have the y coordinate of the turning point. Okay. Let me draw a line here. So when you have a parabola like this, you have to understand that there at that point, this is your turning point. You have your x coordinate of the turning point and you have the y coordinate of the turning point. So when you go there, this is on the x-axis. You have the x coordinate of the turning point at that point. And when you go there on the y-axis, right, you have the y coordinate of the turning point. This is going to make sense when we start solving problems. Okay, so now the axis of symmetry. Let me draw a line here. Let's say you have this parabola. You can see it cutting the x-axis at that point and at that point, and you have the turning point there. So the axis of symmetry of a parabola will go through that point, the turning point. So it will be like this. Okay, you can see the two parts are equal to each other. This part and this part. You can fold the parabola around this axis. When you fold it around this axis, the parts are going to lie exactly on top of each other. So this is the axis of symmetry, which is this line. So if you try to fold the parabola around this line, this part and this part are going to lie exactly on top of each other. So a parabola has got one axis of symmetry. So this line is known as the axis of symmetry, this line. And if you have to find the equation of this line, it's going to be x is equal to the x coordinate of the turning point. Okay, you can see the x coordinate of the turning point there. This is the turning point. The x coordinate is there and the y coordinate is there of this turning point. It's there. So because the line is cutting the x-axis, the equation of this line is x is equal to the value there. The value there is actually the x coordinate of the turning point, this turning point. So this is going to make sense as we move on. Okay, now let's move on. Okay, now we are going to look at the concavity of a parabola. How to tell that a parabola is concave down or concave up. We are going to see that. The first thing that you have to notice in all of the equation is that you have a. So you have a in all the three forms of the equation of a parabola. The three forms of the equation of a parabola are standard form, vertex form, and factored form. We saw that in the previous slide. Okay, so these are the three forms. You can see you have a in all the three forms. There is a, and there is a, and there is a. So the value of a is going to tell you if the parabola is concave down or concave up. The value of a. We are going to see that. Okay, when you have a greater than 0, that means a is positive. Greater than 0, a is positive. The parabola is concave up. Okay, so you have a smiling parabola like this. So you can associate positive with smiling. And the parabola has got a minimum value. It doesn't have a maximum value. You can see this parabola is concave up. This is the lowest point. It doesn't have any other point below this point. This is the lowest point of this parabola. and the parabola still continue to infinity. Still continue to infinity. So there is no maximum value. You only have the minimum value because this is the lowest point of the parabola. You don't have any other point below this point. Okay, so this parabola has got what? A minimum value when it is concave up. So that point is the turning point, and this turning point has got a y value which is found on the y-axis there. In this example, you can see it is 3. Okay, so this is just an example. So this is actually the y coordinate of the turning point, right? This is the turning point. This is the y coordinate of the turning point, right? Because it is on the y-axis. So this is what? This is your minimum value because this is the lowest point, okay? And this turning point has got an x coordinate. So there you have the x coordinate of the turning point. It is found on the x-axis, okay? What if the value of a is less than 0? That means the value of a is negative. The parabola is concave down. So negative with down, or negative with a sad parabola. This is a sad parabola. So you can associate negative with sadness and positive with smile. And the parabola has got a maximum value. There is no minimum value. So this is the maximum value. This is the highest point of the parabola. You don't have any other point above this point. So the parabola has got a maximum value and it has no minimum value. There is no minimum value because the parabola still continue. It still continue to infinity, still continue to infinity. So you don't have a minimum value. You only have what? The maximum value, because this is the maximum point or the highest point of this parabola. So this is the turning point, you know that, and this turning point, you know, it has a value on the y-axis, right, at that point. So this is actually what? The y coordinate of the turning point. This is the turning point, and the y coordinate of the turning point is found on the y-axis. So this is the maximum value of this parabola when it is concave down. It's got a maximum value. And this turning point, remember, it also has got what? An x coordinate. So it's there on the x-axis. So this is the x coordinate of the turning point. This is your turning point. Okay, this is not complicated. It's going to make sense as we move on, as we solve problems. So now, talking about the domain and range of a parabola. To find the domain, for example, for this parabola, which is concave up, the domain is found on the x-axis. You take all the values of x that exist for this parabola. This parabola does not stop here. The parabola still continue. When you extend your axis, you are going to see that this parabola is going to cut the y-axis. So it's going to go this side on the negative side of the x-axis, and it still continue this side. So it's going to go this side on the positive side of the x-axis. So all these values, they exist for this parabola. So the domain is x element of real numbers. All these values, they exist for this parabola. Or you can say that the domain is x element from negative infinity to positive infinity. Okay, from negative infinity, you have this notation from negative infinity to positive infinity. Remember, when taking the domain, you start from left to the right. Always from left to the right. So from left, you have negative infinity. To the right, you have positive infinity. Now, the range of this parabola. How can you get the range? The range is found on the y-axis. So you take all the values of y that exist for this parabola. You can see the parabola start from that point, the y coordinate of the turning point, all the way up. When taking the range, you have to start from the bottom to the top. Always do that. You start from the bottom to the top. And this parabola on the y-axis, it only exists from that point going up. Can you see from that point going up? So you can give it as y because you take the values of y that exist for this parabola. You have y element of, from there, you start from the bottom to the top. So you have a square bracket because this is included, right? This value is included. So you have a square bracket. You have this value. all the way to, you go up all the way to infinity, positive infinity, and you have a round bracket there because you don't know what infinity is. Infinity means we still continue, we don't stop, we still continue to infinity. Or you can give the range as y greater or equal to this value. So you have this value and all the values greater than this value. From there, you go up. This is greater than. Okay, so you have y greater than or equal to. Okay, now if you want to get the domain or the range of this parabola, which is concave down, the domain of this parabola, you take all the values on the x-axis that exist for this parabola. You have all these values. So this is the same as in the previous parabola. So x is element of real numbers, or you can give it as x element of this interval, just as in the previous parabola. Okay, so this is the same. All these values on the x-axis, they exist for this parabola. Now the range, how to get the range? Remember, the range is always obtained on the y-axis. You take all the values of y that exist for this parabola and you start from the bottom to the top. Okay, you can see the parabola is going down, down, and down, and down. You can see. So you start from the bottom. It doesn't stop here. So from the bottom, you have negative infinity all the way to that value. So you have y element of from negative infinity, from down there, it's negative infinity, and you have a round bracket all the way to this value. Can you see? From negative infinity all the way to that value, and you have a square bracket because this is also included in the range. This value is included in the range, so you have a square bracket. Or you can say y, what is this? Y less than this value, right? All these values down, they are less than this value. So you have y less than or equal to this, right? Okay, so this is how you can get your domain or range for a parabola. This is simple. So the secret to master this, you have to solve many problems on parabola. Okay, let's start with examples. Okay, we start with example number 1. So parabola worked example 1. This is the question. Find the equation of a parabola in the form f of x is equal to ax squared plus bx plus c with turning point 1, -4 and cutting the y-axis at -3. Okay, and sketch the graph of f. Okay, let's solve the question. So you start with solution. You can see you are given the turning point. So you can start with this form because you know this is the vertex form, right? You know your turning point. You can plug in there because you are given the turning point. So you can start with this form and then you are going to get this form. So f of x is equal to a, you have x. Now your p, this is your p. When you put it back inside the bracket, you change the sign. Remember that. So this is a positive 1. When you take it inside the bracket, you change the sign. So it becomes -1. Okay, you close your bracket, square. And this is your q. You don't change anything. So your q is -4, right? Okay, your p is 1. When you take it back inside the bracket, you change the sign from a positive 1 to a -1. If it was -1, it was going to be +1. So remember to change the sign whenever you are taking this value inside the bracket. Okay, you can carry on. Now you have substituted your p and q. Now you need to get your a. You can use another point, right? Do not use this point. You have used it. So use another point to get the value of a. You can see you are told that the graph is cutting the y-axis at -3. So you have this point 0 and -3, right? This is the x coordinate and this is the y coordinate. So this is your y-intercept, and at the y-intercept, x is 0. So this is a point on f, right? This point is found on the graph of f. So let's use it. You substitute in there. F of x is your y. Your y is -3, right? This is equal to a. You open your bracket. your x is 0, so you are going to substitute 0 wherever you see x. So you have x there, you substitute 0 minus 1, you close your bracket, square, and then minus 4. Okay, you can see that. So when you take this negative 4 to the left, it becomes plus 4. So you have 4 minus 3, which is 1. When you take this negative 4, so it's 4 minus 3, which is 1. This is equal to a times, this is 1. 0 minus 1 is minus 1. To the power of 2, it's 1. So you have 1 times a is equal to 4 minus 3, right? 4 minus 3 is 1. So the value of a is equal to 1. Now you have the value of a, you can plug in there and then try to get the equation of the parabola in this form. So you have f of x is equal to a, your a is 1, right? A is 1. You have x minus 1, you close your bracket, square, minus 4. Okay, now you have everything here. You can now expand the bracket to get the equation of a parabola in this form. So f of x is equal to, you have 1 times this, so it doesn't change. Okay, so you have x squared, right? And then you have x times negative 1. This is negative x, and then you multiply by 2, which is negative 2x. Okay, okay. And this negative 1 square, it's plus 1, right? And you have minus 4 there. Okay, I hope you can see that. So f of x is equal to, you have x squared, you have negative 2x. These are like terms, 1 minus 4, which is minus 3. Okay, so this is the equation of the parabola in the form x squared plus px plus c. You can see. Okay, now we have the equation in this form. We have solved for this part. Now we have to sketch the graph because the question says, and sketch the graph of f. Okay, let me draw a line here. So to sketch the graph of f, you are going to need the turning point. You are given the turning point. These are the coordinates, right? And you're also going to need the y-intercept. You are given the y-intercept, right? You can see the graph is cutting the y-axis at negative 3. So you have this coordinate. Remember, at the y-intercept, x is 0. And you're also going to need what? The x-intercept. You don't have the x-intercept. So to get the x-intercept, you let y equal to 0 so that you can get the x-intercept. Okay, let's get the x-intercept. You are going to use this equation. So f of x is your y. You substitute it with 0 so that you can get your x-intercept. This is equal to, you have this, right? X squared minus 2x minus 3. Okay, so this can be factorized into two brackets like this. This is equal to 0. Okay, so let's factorize this. You have x squared there, so you are going to have x times x, and then you have negative 3. Which two numbers? When you multiply those two numbers, you are going to get 3, and when you add those two numbers, you are going to get negative 2. You can see 1 and 3. 1 times 3, you can get 3, and from 1 minus 3, you can get minus 2. So you have minus there and plus there, and from here you can see that x is equal to negative 1, okay, or x is equal to 3. And so you have the coordinate of the x-intercept, negative 1 and 0, and the other one is 3 and 0. Remember, at the x-intercept, y is 0, and y is the second coordinate. Always, the first coordinate is your x, the second coordinate is your y, and at the x-intercept, y is 0. Okay, now you have all the information that you need to draw the graph of f. Okay, so you can draw it. This is the graph. You can see this is your x-axis and this is your y-axis. You have the turning point there. At that point, the coordinates are 1 and negative 4, right? 1 and negative 4. There, you can see 1 and negative 4. And you also have the y-intercept. So you can see the parabola is cutting the y-axis at negative 3. Can you see? At negative 3, that point. Can you see that point? The coordinates are 0 and negative 3. And you also have the x-intercept. You have this one. You can see the parabola is cutting the x-axis at negative 1, that point. So the coordinates here are negative 1 and 0. And you have this. The parabola is cutting the x-axis at 3. At that point, the coordinates are 3 and 0. You can see that. So this is how you can draw the graph of a parabola. Okay, now let's look at example 2. Okay, let me do it on the next slide. Okay, now example number 2. Find the equation of a parabola in the form f of x is equal to ax squared plus bx plus c that cut the x-axis at 1 and -4, okay, and cut the y-axis at 12, and also find what the x coordinate of the turning point. So this is the question. You have to find the equation of a parabola in the form f of x is equal to ax squared plus bx plus c. So the parabola cut the x-axis at 1 and -4, right? The parabola cut the x-axis at 1 and -4, and the parabola cut the y-axis at 12. And you also have to find the x coordinate of the turning point. Okay, let's solve the question. So using the information, you can see you have the point 1 and 0, and you also have this point, and you also have this point. Okay, we need to find the equation of the parabola in this form. So you can see you have your x-intercept there, 1 and -4. You can start with this form. This is the factored form because you know the first x-intercept and the second x-intercept, right? x1 and x2. So you can use this one and try to end up with this in the end. Okay, let's use this one. Okay, you can go for another equation. It will still work, but let me go for the simplest one. Since I know my x-intercept, I can use this one. Okay, so f of x is equal to a, you open your bracket, you have x. When you take this, you put it back inside the bracket. Remember, you have to change the sign. Whenever you are taking it inside the bracket or outside of the bracket, change the sign. So from a +1 to a -1, you close your bracket and you have x. Now you have -4. When you put it back, you change the sign again. So from a -4 to +4, you close your bracket. So if I have to take this outside of the bracket, -1, it will be 1. If I have to take this outside of the bracket, +4, it will be -4. So remember that when you take it inside the bracket, change the sign. When you take it outside of the bracket, change the sign. Now you need to get your a. So you are going to use another point, which is not the x-intercept. Use another point, which is on the parabola, to get your a. So I can use this one. My x coordinate is 0 and my y coordinate is 12. So f of x is y and my y coordinate is 12. So you have 12 is equal to a. So you substitute 0 wherever you see x. There's x, there's x. Your x is 0. You are going to substitute 0 wherever you have x. So you have 0 minus 1. You close your bracket, you open your bracket, you have 0 plus 4, right? You close your bracket. Okay, so you have 12 is equal to, this is a, and this is -1 times 4, right? -1 times 4, this is -4. You divide by -4 on both sides. You divide by -4, you have a is equal to 12. You divide by -4, it will be -3. Okay, now you have the value of a, which is equal to -3. You take it, you put it there, and try to expand the bracket so that you can get the equation of a parabola in this form. So you have f of x is equal to a is -3. You have this bracket times this bracket. So you have x times x is x squared, right? You have x times 4, which is plus 4x. You have -1 times x, which is -x. You have -1 times 4, which is -4, right? You close your bracket, and f of x is equal to, you have this x squared times -3, which is -3x squared. You have 4x minus x, this is 3x, and you multiply by -3, which is -9x, right? This is 3x, 4x minus x is 3x, times -3, which is -9x. And we have -4 times -3, which is plus 12. Okay, minus times minus, it's plus 4 times 3, right? It's 12. Okay, so you have now the equation of a parabola in the form f of x is equal to ax squared plus bx plus c, this form. Okay, now to find the x coordinate of the turning point, you have three options. Okay, you can use the formula x is equal to negative b over 2a, or you can use calculus. You take the first derivative of this, you equate it to 0, and you solve for x. That x is the x coordinate of the turning point. Or you can use this formula. X, the x coordinate of the turning point, is equal to, since you know your x-intercept, this one and this one, you take this value plus this value, you divide by 2, because the x coordinate of the turning point is halfway in between these 2 points. So you take this value 1 plus the second value, which is negative 4, over 2, right? This plus this over 2, and this is equal to, we have 1 minus 4, which is negative 3 over 2, right? 1 minus 4 is negative 3 over 2, right? Negative 3 over 2, and this is equal to, in decimal, this is equal to negative 1.5 in decimal. So you have it as a fraction or as a decimal. So you can use this formula to find the x coordinate of the turning point, or you can use the formula x is equal to negative b over 2a, the one extracted from the quadratic formula. Or you can use calculus. You take the first derivative of this, you equate it to 0, and you solve for x. So you have three options. So I have used this one. So we are done with parabola grade 12 or quadratic functions grade 12. This is part 2 of 6. Please check for part 3 of 6, which will be on hyperbola. Okay, so for now we are done. If you find value in this video, please show that with your likes. Comment in the comment section. Remember to subscribe and activate the notification bell so that you can be alerted whenever a new video is posted on the channel. Until next time, I will talk to you soon.